Good morning, students. So welcome back. Today we are going to begin with the new topic, triangle and properties of triangle. So basically, what is a triangle? A triangle is a closed figure having three sides and three angles. And the elements of triangle, how many elements are there? There are 6 elements, 3 angles and 3 sides. So how we write them? Segment AB, segment BC and segment AC. These are the sides of triangle. Then angle ABC, angle BAC and angle ACB. These are the 3 angles of the triangle. Total 6 elements. Okay. Now, these are 3 letter names. We can write the names of angles in 3 different ways. Angle ABC or angle CBA or angle B. Angle BAC or angle CAB or angle A. Angle ACB, angle BCA or just angle C. So, we can write the names of the angles in 3 different ways. Okay. Now, the angle opposite to side AC is which angle? Yes, exactly. Angle B or angle ABC. The angle opposite to segment AB is angle ACB. Or the side opposite to angle A is segment BC. So we know the opposite angles to the particular side or opposite side to the particular angle or a vertex. Now let us study about the regions of the triangle. Now triangle, the area of triangle can be divided into 3 regions: exterior of a triangle, interior of a triangle and on the triangle. So suppose these are the points P, Q, R. Name of the triangle is ABC. Suppose this is point X here, here it is Y, here it is S, T. So the region inside the triangle is called as the interior of the triangle. So here point P, point Q, point R, they are in the interior of the triangle. Whereas the region outside the triangle, it is called as exterior of the triangle. Here point X, point Y, they are in the exterior of the triangle. And the points which lie on the edge of the triangle, they are said to be on the triangle. For example, point S, point A, point B, point C, point T, they lie on the triangle. And the interior of the triangle as well as the points on the triangle, together they make triangular region. Points inside the triangle and on the triangle, together they make the triangular region. Okay. Now the next point, that is exterior angle. Exterior angle of a triangle. The angle which forms linear pair with the angle of a triangle is called as the exterior angle of the triangle. I repeat again the definition. The angle which forms linear pair with the angle of a triangle is called as the exterior angle of a triangle. Linear pair, sum is always, oh yes, obviously it is 180. Now see here, angle ACB is the angle of triangle and angle ACD, that is this angle, is in linear pair with this angle. So angle ACD is also the exterior angle of triangle ACB. So how many exterior angles I can get? Now see here, this and this, oh yes, they are exactly vertically opposite angles, and hence angle BC, suppose this is E. So angle BC is also exterior angle. Check the condition whether it is in linear pair with the angle of the triangle. See here, angle ACB and angle BCE. Are they in linear pair? Yes. These are the opposite rays. So hence it is, these both are linear pair. So at one angle of a triangle, you always get two exterior angles. And both these exterior angles, mind it well, they are always congruent. They have to be because they are vertically opposite. So two angles at one vertex. So total how many angles I can get? So here also I will get two more angles. Here also I will get two more angles. So this is 1, 2, 3, 4, 5, 6. So there are how many exterior angles? 6 exterior angles of a triangle. And one more question. Now, is this an exterior angle? It is not the exterior angle of the triangle. Why? Because it is exactly equal to the angle of the triangle. And that is not correct. Because now these are vertically opposite angles. It is not the exterior angle. So there are only 6 exterior angles of a triangle. Keep this in mind. Okay. And exterior angles at a given vertex. For example here, these both are congruent. These both are congruent. These both are congruent. Because they form linear pair with the same angle of the triangle. And one more property. One more property is that the sum of remote interior angles of a triangle is always equivalent to its exterior angle. In other words, the measure of exterior angle of a triangle is always equivalent to the measure of its sum of measure of its remote interior angle. It is also called as exterior angle theorem or interior angle theorem. Okay, for example, if this is 130, okay, now if this is 130, this is going to be 50 degree. Am I right? Yes, it has to be linear pair angle. Now see, now sum of this three angles of a triangle angles of a triangle is always 180 degree. From that, this is 50. So 180 minus 50, 130. So sum of these two angles is 130. That's what we are showing it. That sum of remote interior angles, that is, which are away from this angle. So sum of the remote interior angles is always equal to its exterior angle. Mind it well. Okay, and this is also called as exterior angle property or interior angle property. Okay, now, so you got this, I hope. Now, let's move to the next part of the topic, that is, as I have said, measure of angles of a triangle is always 180 degree. Now let us study types of triangles on the basis of angles. Suppose if the, types of angles, yes, when the measure of the angle is less than 90 degree, it is acute angle. When the measure of the angle is exactly 90 degree, it is right angle. And when the measure of the angle is more than 90 degree, it is obtuse angle. Now, based on the types of the angles present in the triangle, we can classify the triangles into three types. First, acute angle triangle. This is based on the angles of a triangle. Okay. So, classification of triangles based on angles of a triangle. Acute angle triangle. What is acute angle triangle? A triangle whose all the three angles measure less than 90 degree are called or is called acute angle triangle. A triangle whose all the three angles are acute, it is called as the acute angle triangle. Then second is right angle triangle. A triangle in which one of the angle is right angle is called as the right angle triangle. Only one angle is going to be the right angle. Why? Because sum of the three angles of a triangle is always 180 degree. So, you cannot have two right angles in a triangle. Why? Because then third angle will not exist only. because third angle will become automatically 0. So that is not possible. So there is always one right angle in a right angle triangle. You cannot have two right angles. Okay, keep this in mind. Then third, obtuse angle triangle. If one of the angle of a triangle is obtuse angle, then that triangle is called as obtuse angle triangle. So more than 90 degree. Okay, again, in a triangle there can be only one obtuse angle. We cannot have two obtuse angles because the measure will go more than 180 degree, and we know that sum of the measures of all the three angles of triangle is always 180 degree, whatever may be the case. So if there are two obtuse angles, third angle will not exist only, and that is not possible. Then it is not a triangle, and hence there is always one obtuse angle in obtuse angle triangle, or there is always only one right angle in a right angle triangle. We cannot have two right angles, or we cannot have two obtuse angles in a triangle. Keep this in mind. Now, types of triangles based on the side. On the basis of sides, the triangles can be classified again into three types. One, when none of the side is congruent, they are called as scalene triangles. Each side is of different measure. Now this is a scalene triangle. Okay, each side is of different measure. Then, when any two sides are congruent or equal, then that triangle is called as isosceles triangle. So two sides, they are congruent. Okay, two sides are congruent. Then equilateral triangle. When all the three sides of a triangle are congruent, then it is called as equilateral triangle. All the three sides, they have to be congruent. Now the speciality of equilateral triangle is when all the three sides are congruent, all the three angles are also congruent, and hence measure of each angle of equilateral triangle is always 60 degree. Is always 60 degree, because 60 plus 60 plus 60, 180. Isosceles triangle, the speciality of isosceles triangle is the two sides are congruent, and the angles opposite to that two sides, that is this angle and this, base angles of that triangle, we call them as base angles, they are also congruent. Now measure of that changes. Okay, that depends upon the what angle is the third angle, what measure is the measure the third angle has. Depending upon that, the measure of these two angles will change, but they will be equal. Okay, now here it is always 60 degree for equilateral triangle. Now there are more types based on both by angles and sides. We can have isosceles right angle triangle, okay, we can have isosceles right angle triangle. Now when it is isosceles right angle triangle, keep this in mind, this angle is 90, so these two angles, they are going to be 45, 45. So it is also called as 45, 45, 90 triangle. Okay, it is isosceles right angle triangle. Or you can have isosceles scalene, isosceles acute angle triangle. Okay, all angles are acute. Or you can have isosceles obtuse angle triangle. These two sides are congruent, so these base angles will be congruent. Okay, so you can have different types of angles. Now let's move to the next part, that is concurrence in a triangle. So concurrence in a triangle. What is concurrence? We have studied concurrent lines. When three lines, three or more lines, they meet each other at a point, or they intersect each other at a point, then that three lines are called as concurrent line, and the point is called as point of concurrence. We know that. Same way, we are going to study the concurrence in triangles. So first, in case of altitudes of a triangle. Now what is the altitude? A segment drawn from the vertex perpendicular to its opposite side is called as the altitude of a triangle. What I mean to say. Suppose this is a triangle. A segment drawn from the vertex of a triangle perpendicular to its opposite side. Segment drawn from the vertex of a triangle perpendicular to its opposite side is called as the altitude of the triangle. It is also called as the height of the triangle. So this becomes the base. Okay. So if I want to find area of the triangle, it becomes half base into height. So if I know the base, if I know the height, I can find the area of the triangle. Okay. Now we are not related to area, we are related to altitudes only. So let us focus on altitudes. Now I can draw second altitude. Okay. And this is the third altitude. So you can see the altitudes of a triangle are concurrent because they intersect each other at a point. Now this point is called as point of concurrence, and it is also called as orthocenter. The point of concurrence in case of altitudes is called as orthocenter. Okay, and in case of acute angle triangle, you can see the orthocenter is inside the triangle, in the interior of the triangle. Now let us check for right angle triangle. Now this is right angle, am I right? Now if this is right angle, so both these are altitudes of the triangle. Where is the third? Drop the third altitude from here, like this, just a minute. Okay? Now this becomes the third altitude. So where they meet? At the vertex where right angle is made. Okay? At the vertex of the right angle. So orthocenter is here. Orthocenter lies on the vertex of right angle. Okay, so that is the orthocenter. Now in case of obtuse angle triangle, so suppose this is obtuse angle triangle. So first I will drop it here. Just a minute, I will drop this. Because I will require more space. So I will rub this second figure. And now I can draw. So first here. So this is the right angle here. So this is first altitude on this side. Now altitude on this side. So what you need to do? You need to extend here. See, like this. And from here the altitude will come. Extend it below. Now here it makes the right angle. So this is the vertex opposite to this side. That is most important. And so how I can draw the perpendicular here? Straight away. Use set square. You will be exact. Okay. Now which side is left? This. So which is the opposite vertex for this? Here. So I need to extend here like this. Okay. And then I am going to drop the perpendicular. So this is the perpendicular. This is the side and this is the opposite vertex. We have got the altitudes, but do they meet? Here for time being I am not able to get them intersecting each other. So what to do? Increase them, extend them, and see here. Where they meet? Here. Yes, this is the orthocenter. So, for acute angle triangle, orthocenter lies in the interior of the triangle. For right angle triangle, orthocenter lies on the vertex having the right angle. And for obtuse angle triangle, the orthocenter lies in the exterior of the triangle. You try this. Okay, try various types of obtuse angle triangle. You will get them. Use set square but to draw these altitudes. Okay, and your concept related to opposite side to the given vertex. That is most important. If you know them, you will not make mistake. Okay, now after these altitudes, let's move to the perpendicular bisectors of the sides of a triangle. So second, perpendicular bisectors. Of the sides of a triangle. Now what are perpendicular bisector? We have drawn, we have learned. Suppose this is the segment and I want to draw a perpendicular bisector. So what I do? I take a compass, right? Then I take more than half and then I draw the arc like this from this point. And with the same distance, keeping the pointer here, I draw the another arc like this. Okay, and I can draw the perpendicular here like this. I can join these arcs. So this becomes the perpendicular bisector. We have learned this. Same way we can draw the perpendicular bisectors of the triangle. Okay, so a perpendicular segment which divides the side of a triangle into two equal parts is called as the perpendicular bisector. Okay, now see here. This is the midpoint. So suppose if I draw it like this, and here, so you can see here the perpendicular bisectors also meet at a point. They are also concurrent. Now, in case of perpendicular bisectors, now this is for acute angle triangle. This point of concurrence is called as circumcenter. What it is called? It is called circumcenter. And using this circumcenter, we can draw circumcircle. Now, what is circumcircle? A circle which passes through the vertices of the triangle is called as the circumcircle. So, with this as the center and this as the radius, with this we draw a circle which passes through all the three vertices of the triangle is called as the circumcircle. Okay, and this point of concurrence of perpendicular bisectors is called as the circumcenter. Now, in case of acute angle triangle, it lies in the interior. Let us check for right angle triangle. Exactly. Now, suppose this is the right angle triangle. Okay. Now, this is the half midpoint. This is the midpoint. Okay, it lies on the hypotenuse. It is midpoint of the hypotenuse. Okay, so perpendicular bisectors, so third will be here like this. So the circumcenter is the midpoint of hypotenuse. Okay, it is the midpoint of the hypotenuse, and so that will help you. Now, next, yes, obtuse angle triangle. Let us see for obtuse angle triangle. Now suppose this is the obtuse angle triangle. Now this is my perpendicular bisector of this side. Then for this side, okay, this is the perpendicular bisector here, and for this side it is somewhere here. Okay, now you can see they meet in the exterior of the triangle. So the orthocenter lies in the exterior of the triangle. Not orthocenter, circumcenter. The circumcenter lies in exterior of obtuse angle triangle. Okay, so after this, let us go for angle bisectors. Angle bisectors, you know, that is the ray which divides the angle into two equal parts. So suppose this is first, this is second angle bisector, and this is the third. So it divides the angles into two equal parts. Okay, and you can see again they intersect each other at a point. So that point of concurrence is called as incenter. What it is called? It is called incenter. Okay, and with that as the center, you can draw incircle. Now what is incircle? That is the circle which touches all the three sides. So with this as the center and this as the radius, this distance, you can draw a circle which touches all the three sides. So that is called as the incircle. Okay. Now this point of concurrence, which is called as incenter, for acute angle triangle, it lies in the triangle. For right angle triangle, let us see. You can judge. Okay. Now this is my first angle bisector, this is my second angle bisector, and this is my third. Where it lies? Yes. For right angle triangle also, it lies in the interior of the triangle. Then for obtuse angle triangle. For obtuse angle triangle again, the angle bisector is like this. This is second angle bisector, and this is third. Where it lies? Yes. Incenter lies in the interior of the triangle. Okay. Now after this, construction of triangles. We can construct triangles based on the tests: SAS test, SSS test, ASA test, and hypotenuse side test. When all the three sides are given, we can construct the triangle. When two sides and the included angle, SAS, side angle side. When two sides and the included angle is given, we can construct the triangle. Then when two angles and the included side is given, ASA test. Okay, so we can construct the triangle. And then in a right angle triangle, if hypotenuse and side is given, we can construct the right angle triangle. So construction of triangles can be done. Now let's move to the correspondence between the vertices of a triangle. Suppose if triangle ABC and triangle PQR are two triangles, and if I cut triangle ABC and place it over as it is here, so my triangle ABC will be like this. So A is placed over P, B is placed over Q, and C is placed over R. So here we can say A is in one-to-one correspondence with P, means it matches there. Okay. B is over Q, that is B is in one-to-one correspondence with Q. C is in one-to-one correspondence with R. So this is called as one-to-one correspondence. Okay, means what? How we can write? A, B, C is in one-to-one correspondence with P, Q, R. Means A is placed over P, B is placed over Q, C is placed over R. How many different ways we can write this one-to-one correspondence? Let us check it. Keep one triangle fixed and keep the vertices of another triangle changing. Okay, so here, see here, A, B, C is in one-to-one correspondence with P, R, Q. I have kept one vertex fixed. I have changed this. Now, A, B, C is in one-to-one correspondence with R, P, Q. Now keep this fixed, change this. A, B, C, R, Q, P. Then A, B, C, Q, R, P, and A, B, C is in one-to-one correspondence with Q, P, R. So we can write the one-to-one correspondence for any two triangles in 6 different ways. We will consider one of the correspondence. For example, this first one, A, B, C is in one-to-one correspondence with P, Q, R. From that we can write the corresponding sides and corresponding angles. So I can write the corresponding sides. Okay. Now what will be the corresponding side? PQ is in one-to-one correspondence with AB. So AB is in one-to-one correspondence with PQ. You can see here, AB, PQ. Now if I take BC, so BC is in one-to-one correspondence with QR. Check it there in the figure. BC. Where is BC? Here. BC is in one-to-one correspondence with QR. Yes. Then AC. Then AC is in one-to-one correspondence with AC to PR. Check it. AC to PR. We can write the corresponding angles. Corresponding angles. Angle ABC is in one-to-one correspondence with ABC, that is angle B. Angle PQR. Then angle BAC, that is angle BAC is in one-to-one correspondence with BAC. So QPR, angle QPR. Then angle BCA is in one-to-one correspondence with BCA, QRP, angle QRP. So you can see, we can write, if for a given one-to-one correspondence, you can write the corresponding sides and you can write the corresponding angles. Now as I have said, we can write the correspondence in 6 different ways. For a given one-to-one correspondence, the triangles may match exactly like this. That is, the sides of that triangle will be exactly equal to the sides of the another triangle. The angles of the triangles may be exactly equal to the angles of that another triangle. At that time, we call the two triangles as congruent triangles. And we represent the congruent triangles by this symbol. This is called as the symbol of congruency. So when for a given correspondence, the 3 sides of a triangle are exactly equal to the 3 sides of another triangle. The 3 angles of a triangle are exactly equal in measure to the 3 angles of another triangle. Then the 2 triangles are said to be congruent. For example, suppose if these 2 triangles are congruent, then triangle ABC will be congruent to triangle PQR. So depending upon that correspondence, we can write the congruent angles and congruent sides. Suppose for this correspondence, these two triangles are congruent. Triangle ABC is congruent to triangle PQR. We can write the congruent sides. Now it is congruent. Okay. So congruent sides will be segment AB congruent to segment PQ, segment BC congruent to segment QR, segment AC congruent to segment PR. Similarly, we can write the congruent angles. Angle A will be congruent to angle P. Angle B will be congruent to angle Q. And angle C will be congruent to angle R. I have written single letter name. You should always write 3 letter names. Okay, that is angle ABC congruent to angle PQR. Angle BAC congruent to angle QPR. Angle BCA congruent to angle QRP. Okay, so we can write for given one-to-one correspondence, if the two triangles are congruent, we can write the congruent angles and congruent sides. Okay, now let us check the correspondence. For given correspondence, what type of triangles are congruent? For scalene triangle, if there are two scalene triangles, they are congruent only for one correspondence. If you have got two isosceles triangles, if they are congruent for one correspondence, then they will be congruent for one more correspondence. Okay, and for equilateral triangle, they are always congruent for all the 6 possible correspondences. Okay, all the 6 correspondences. Now, test for congruency of triangles, as I have said, SAS test, that is side angle side test, SSS test, then ASA test, and hypotenuse side test. These are the tests for congruency. One more thing, whether we can construct a triangle or not, without measuring the length or without actually drawing the figure, we can decide. How? By seeing the lengths of the sides and by doing the addition and subtraction. Remember that sum of the lengths of two sides of a triangle is always greater than the third side. And the difference of two sides of a triangle, lengths of two sides of a triangle, is always smaller than the third side. If this follows, then you can construct a triangle. If this rules does not follow, we cannot construct a triangle. So dear friends, theoretical part I have completed today. We will solve the related exercises in my next video. So let us stop here today. Go through all these points. If there is any point that you have not understood, definitely you can contact me. So let us stop here today. We can meet in next video. Till then, goodbye. Thank you.